Among the great curiosities that the vast topography of our planet possesses, the mountains stand out a special attention, since if we think of them, words immediately arise in our heads that act as synonyms of what they represent: majesty, grandeur, and history. And it is that, for the purposes of this video, it is necessary to put the latest one, history, in the forefront, since much has been discovered by studying these terrestrial colossus about the tremendously complex geological processes that occur in the tectonic plates that lie under these formations. One of them of special consideration, the famous Mount Everest located in the Himalayas. Being the formation with the height of more than 8,000 meters, holder of the record of the highest altitude on our planet, it is inevitable to think how such formation could reach such a shape. Being that also, his more direct brothers are also located in the same mountain range. Will there be some underground geological process that generates it, or is it just a coincidence? Hello, welcome to Amazing Worlds in English, a space of knowledge where you will learn more about the universe that surrounds us, the planets and stars that are part of it, and above all, our beloved planet Earth. As you know, today we'll be talking about how Everest was formed. I invite you, if you have not yet subscribed to the channel, to do so and activate the bell to be notified of the next topics that will be released very soon. Once the introduction is done, and with nothing else to add, let's begin. As we mentioned at the beginning of the video, with a height of at 8,848 meters, Mount Everest holds the record for being the highest mountain in the world. His name in Nepali, Sagarmatha, means front of the heaven. It was discovered in 1830. It is located in the Himalayas on the border between Nepal and China. This mountain range also has peaks with altitudes close to what the Everest holds, such as the Lhotse Peak with 8,560 meters, Notsi with 7,855 meters, and Shanxi with 7,580 meters. These very particular circumstances, where coincidentally the highest mountains in the world are found in the same mountain range, makes us consider the theory that the same geological process that gave rise to the creation of Everest, and therefore its characteristics and height, also had to do directly with the formation of this mountain range. Therefore, studying this topic requires understanding the underground phenomena of the area in its entirety. To begin with, the formation of Mount Everest occurred approximately 20 to 24 million years ago during subduction, that is, the sinking of one tectonic plate under the other of the Indian plate. As a result, the partial fusion of high-grade metasedimentary rocks of the upper Himalayan sequence from the Paleoproterozoic to Ordovician period. Mount Everest is made up of sedimentary and metamorphic rocks that have been pushed south over the continental crust, composed of Archeozoic granulates from the Indian plate during the Cenozoic collision of India with Asia. Current interpretations argue that the Everest and North Col formations are formed by marine sediments that accumulated within the northern continental shelf and the continental boundary of India prior to the collision with Asia. India's collision in the Cenozoic with Asia subconsciously deformed and transformed these strata while pushing them south and upward. The Rambuk Formation is made up of a sequence of high-grade metamorphic rocks and granitic rocks derived from the alteration of high-grade metasedimentary rocks. During India's collision with Asia, these rocks were pushed down and north as they were pushed up by other strata, heated, transformed, and partially molten at depths of more than 15 to 20 kilometers below sea level, and then forced up to the surface, pushed south between two major detachment faults. To illustrate in another way, the thick Indian continent plate, as it was compressed under Asia, the surface gave away and the crust began to thicken, resulting in the formation of what will eventually become the Himalayas. Now, under the blanket of snow that covers Everest, there is an extension of rocks that were discovered that previously lay on the bottom of the ocean. Furthermore, about 70 meters below the summit of Everest, this area is composed of trapped sediments, imprisoned and held together by biofilms of microorganisms, especially cyanobacteria, which can be found in shallow marine waters. Everest is composed primarily of lower Ordovician limestone interbedded with secondary beds of recrystallized dolomite with layers of clay and siltstone. Near the summit, it was found composed of compressed carbonate stones and fragmented remains of trilobites, crinoids, and ostracods, all of them marine organisms, which supports this theory. It is also composed of metamorphic rocks, which appear to be the result of Middle Cambrian to Early Cambrian metamorphism of deep ocean sedimentary rocks. In another order of ideas, in an article of the National Geographic, the formation of Everest is, in this way, summarized. Everest, located on the border between Tibet and Nepal, was formed due to a violent tectonic clash between the Indian and Eurasian tectonic plates tens of millions of years ago. The collision rent the landscape, raising mountains for some 1,500 miles, a range we now know as the Himalayas. Although many mysteries remain about the exact steps this continental collision followed, the collision continues to the present day, which is part of the reason why Everest's height continues to change. This constant movement of the plates makes it possible for the Himalayas to rise about 5 millimeters per year since the collision that formed Everest continues today. Other estimates suggest that India is moving north by about 4 centimeters each year, and scientists believe that the impact with Eurasia could cause the mountains to rise to greater heights, with an estimated average rise of about 10 millimeters a year into the northwestern sections of the mountain range, and almost a millimeter a year on Everest. To conclude, the formation of Everest and the particular geographical area where it is located has been a constant victim for millions of years of profound geological changes, a product of the very interesting processes that occur on our planet, and which will certainly continue to occur. The actual discovery that these changes are still and will continue to occur to Everest's natural topography and the slow but steady increase in its altitude makes us wonder what shape it will take in the years to come. Dear YouTube friends, here is today's video. Please do not forget to like, share with your friends this incredible information about how the Everest was formed, write us in the comment box to let us know your opinions and concerns about the subject in question, and subscribe to learn more about the universe that surrounds us, the planets and stars that are part of it, and above all, our beloved planet Earth. Until the next video.